From Apple's website, trying to find a data scientist for their iCloud platform. They want someone to perform ad hoc data analysis, build big data assets using Scala, Python, and other big data SQL technologies, program in Java, Python to develop predictive forecasting models, devise advanced statistical machine learning methods to improve current KPI. They want experience in data engineering in big data systems, expertise in crafting data models for high performance and scalability, experience with Spark, Hadoop, or any other distributed frameworks, strong data mining and statistical modeling background. As you can see, most data science roles mention big data. But what is big data and why is it so important for a data scientist? Stay tuned and I'll tell you more about this. So, welcome back, guys. Welcome to another channel episode. This is the channel where we talk all about how you don't need to be a CEO in order to have some impact on the world. And what I just read to you was a Apple data scientist for their iCloud role. And in the role, they talk all about big data. In fact, they talk very little about data science tools and they talk mainly about distributed frameworks. This week in my bootcamp was all about big data. Now, when I came into this, I had no idea what big data was all about. And I had heard the word big data before, but I didn't really know what it meant. So in this video, I'm going to try to clear up some things for you and what are the necessary technologies to understand big data and how you can check on other job offerings what kind of big data tools they use so you can optimize for that. So as you may know from the title of this episode, this week I learned about big data in my bootcamp. Now, coming into this, I knew nothing about big data, and I was eager to learn what I needed to know. And what turns out, what I needed to know was all about these frameworks, these different tools in order to manage big data. Now, let's define big data. What's big data? Well, big data is really simple. Big data is just data that's too big to fit on one computer. It's data that's being updated too often. It's data that's too large, too much volume, and because of this, it needs multiple computers. It needs to be spread on multiple computers. It needs to be on a database and not just on a file on your computer. So we have tools like SQL, which is a really popular one that deals with relational databases. But SQL is kind of old, so we have other options, and these other options include MongoDB and Spark, and all these tools are basically just different ways of managing big data. And most jobs want you to know a couple of these. Like Apple, they want you to know SQL, they want you to know Spark, maybe even Hadoop. And there's so many different ones, and you got to know for your job what they want in order to optimize for that. But when you're just learning, it's a good idea to learn all of them because you never know which one you might like more. For example, in my case, I thought I would enjoy MongoDB more than SQL because it was just newer. It's more flexible. MongoDB grabs what happened in SQL, the technology from SQL, and makes it a little bit easier. Updates it, makes it less harsh, less concise. It makes it easier to use, specifically for doing things like web scraping or data that's not easily, categorized in these, certain types like in SQL. But I find SQL is just so much easier to understand, and due to the rigidity, it makes it very easy for finding what you want to do and very easy to do things like joins and where statements and joins. So you got to use all the different tools in order to find out which one works best for you. Moving on, I also learned about Spark. Spark I knew nothing about before, but wow, Spark is really cool. Spark has its own kind of database system. The other two deal with relational databases. Spark deals with more RDDs, which are different types of databases, and they're also very, very structured, and they actually don't update the database until you send a request to get information back. So they do something that's called lazy execution is the actual term for it. And basically it's a way to optimize. It's a way to be the most efficient way possible. Again, Spark is an update to what SQL used to do. Now, because SQL is so common in almost every data science job, every tool for a data scientist is going to have some SQL built in. So Spark actually has SQL inside, like you can build on it. So you can then use PySpark in order to use SQL queries in Python using Spark, using a database that, again, is not on your computer, but elsewhere in a cloud. And I think that's just fantastic. That's just a really cool and easy way to deal with big data while still using SQL and Python and being ready at a second's notice to pull something using Spark, manipulate it using SQL, and then going into Pandas, going into Matplotlib, opening a Jupyter notebook, and working on what you want to work on with the data you've selected. So I think that's an awesome workflow. I think everyone should learn that workflow if they're trying to be a data scientist. And I think it would be necessary for this Apple data science role. So that was kind of the database technologies that I learned in dealing with big data, and I was fascinated by how just many options you have, especially when it comes to SQL. There's so many different. There's even no SQL, which is crazy. And then you have another big data system that is less has to do with the data and the files itself, but has more to do with computers and engineering and dealing with different programs in different computers. When you have something like AWS, right, which is Amazon Web Services, which every data scientist must have heard because it's a great way to use extra GPUs in the cloud and Amazon's computer, huge computer somewhere else, and you can just pull the answers back. And the way they do that, the way they give you a computer is they make an instance in their computer, and it's like a container almost, or a mini computer that listens only to what you have to tell it until you turn it off, and then it does the work of someone else. Now that's such a cool and interesting idea because you can then run a Jupyter notebook on your computer that may not be strong. In fact, it might even be an iPad. You can do this on an iPad or an iPhone, and then spin up a computer somewhere else in AWS, use it, get your answers back, shut it down, and then you have your work. And this flow can actually happen within seconds. So if I want to run a machine learning algorithm that might take 12 hours on my iPad, why would you do it on your iPad? But it's possible. You can do it on your phone if you'd like. It would take 2 seconds, even less, possibly doing it on their servers if you got a big enough container, big enough computer. Now, a cool part about that is you can actually copy that idea of running a computer elsewhere in AWS on your own computer, and that's actually called Docker. Docker is this wonderful kind of new idea that has been almost revolutionary in the sense that a company can now have kind of containers, and it can give you this container, or this computer can give you the programs, it can give you the data all in this container that you can then download the image, right? Kind of like from GitHub, you can download other people's code. Here you can download someone else's computer file and run that computer inside your computer in order to have the same exact computer setup. And this environment is so necessary for someone that's doing things with big data, because let's say you're dealing with a server in your computer that runs Linux and you're running Windows, and you do a bunch of work on your computer, you give it to someone else, they try to run it and they can't run it because you use Windows and they're using Linux or any Unix kind of system. So using Docker, you can actually spin up the computer, small computer, inside your own computer. So inside your Windows computer and do all the coding there. And then when you send it to your friend, you also send, not only do you send your code and what you work, but you send the container, your environment that you worked in, to them, and they can then load up that container, load up your work, and it'll run the first time. Because if it works on your computer, it works on their computer, because the container is the same. This is such a cool idea, and it's exactly what happens with AWS. You know, AWS, when you're using it to run instances in order to do some, you know, in case you need extra computational power, you want to run something for 12 hours and you don't want to do it on your laptop, sure, you can do this. And the idea is kind of the same. You got this container, this computer somewhere else, it's an environment. You got to load it up. You got to go inside of it. Usually all these systems use Linux. It doesn't necessarily have to be, I think, but almost all of them do. And so you can run it over there, and then you can send it to your friend from it. You can send him the AWS link. They can load it up. They can check what you did, and you can share. You're using the same environment, which is so cool. Now, as I mentioned earlier, Docker is the same thing, except more small scale, more inside the company or just in a group of friends. And it's almost like GitHub for your different computer setups and your different environments, which is so cool. And even smaller than that would be the Anaconda setup. Most data scientists download the Anaconda setup because it's got all the tools, all the libraries from Python that you want kind of inside. This is kind of the same system, the same idea of environments, and you can share the environment and someone else can run the code, no problem. So that's just kind of a glimpse of the things I learned this week. We learned things like SQL. We learned things like MongoDB. We learned things like NoSQL. We learned things like Spark. We learned things like PySpark and AWS. And we learned things like Docker. And all these tools are actually words that are in every single data science role that I've looked on that are requiring a couple years of experience and the use of these tools, proficiency in these tools. And it's come to a point in time where I think that someone really cannot get hired in this data science role without knowing these tools. So that was my week, and it was also the end of the video. Let me know what you guys think in the comments below, which big data system you guys are using in your company, or if you're trying to get hired, which distributed framework you're trying to learn in order to deal with this big data and wrangle your data and mine for your data in a way that's possible in, you know, tiny machines at home. So I'll see you guys in the next one. Peace.